So we're talking about integration by substitution. So this is an important method of how to integrate. I'm going to start this one. Let's say if there's one thing that kind of summarizes this unit, it's substitution method. It's pretty important. So you can call it integration by substitution. Often it's called U substitution, because what you do is you substitute a U for your function. Okay, so here's why we need this. We know how to do the antiderivative of like sine, right? Or x squared. But we haven't seen how to do, let's change that to x to the 8th. But we don't want to do the derivative, or sorry, antiderivative yet, of like x minus 4 to the 8th power. 2x minus 4. Or if it was like sine of 3x minus 1. So what I'm going for is a composition of functions, and therefore this is the reverse, essentially the reverse of the chain rule. Okay, so remember how like we first started off derivatives of sine x, and then we did, okay, sine of 3x minus 1. And we had to do chain rule for that. So basically here, if you see a composition of functions, so I'm going back to chain rule stuff, if it's not just this, but it's, where the variable normally is, it's something else. Then you're going to have to do U substitution. For derivatives, it was chain rule. Okay, so this is called substitution method. Here's what it says. Okay, if capital F is your antiderivative, right? So you do the derivative of your antiderivative, and that is f, lowercase f. They're just saying capital F little f is the original. The integral of little f with u plugged in times u prime is equal to the antiderivative with u plugged in, plus c, of course. So what we're going to do, that looks confusing, but what we're going to do is substitute something in for the inside of our function. You can use any variable, but the topic is u substitution. We use a u as the variable. And right here is the key. If you can get whatever you chose for u, if you can get the derivative of u prime, right there on the outside, multiplied, then you can essentially just go backwards and the chain rule, and you can do the antiderivative. I think I said that here. To get the inside function to exist somewhere on the outside. If I can say real quick, the reason is that for that is, remember when we did the derivative, it was always with chain rule, it was like cosine 3x minus 1 times the derivative of the inside. Where we're trying to get, we then did the derivative of this on the outside. So this is the reverse. If we can get the derivative of our u on the outside, we can go backwards to the original. Okay. So really, the reason this works is all because just backwards chain rule. Then you can take the interval. Okay. That's basically it. Well, let's try some examples. Any initial thoughts though before we do? Okay. Let me show you what the process on this first one, and then I want to show you when we get to the end. I want to show you like, what we really did is we got the derivative on the outside. So evaluate the following integrals. The integral of 3x squared sine of x cubed dx. So this is what I'm going to go through soon. Is like, all right, you got to identify: is it an antiderivative, is it u substitution, or is it some other method? This one. Right there, I'm already looking. It's not just a straight up antiderivative because it's not sine of x. It's sine of x cubed. Okay. Ooh. I don't know what happened. All right. So what I'm going to do though is, if I see a composition, x cubed and sine x, right together, that's a composition of functions. I'm going to let u generally be the inside function. Okay. Let u be the inside function. Now, we'll see coming up where sometimes we want to pick something else, but you choose a u value. Then I'm going to do, let's see if one is. Yeah. Then I'm going to do the derivative of this, because what I want is this derivative to exist on the outside. Okay. So I'm I'm going to do du, just for verification. Du is u prime. Alright, the derivative of u. But just when you do these, you generally write it as du instead of u prime. So I'm doing the derivative of u with respect to x, the variable x. It would be 3x squared. I'm going to write in dx as well. So when I integrate here, I got the correct variable. Okay, so then I've got, let me start to fill this in. I'm going to write the integral, so now I'm going to go back to here. I'm going to do this part here. I got sine, and then in place of x cubed, I'm putting in u. Okay, now, do we have this outside of sine x cubed? We have 3x squared dx on the outside. Yeah, we do. It's right there. So really what I'm doing is I'm just substituting. I'm plugging in here as well. I'm replacing 3x squared dx with du. I'm putting that in. This replaces both those. And what I've now done is now I know the antiderivative of just sine of u. Different variable, but I changed it, and now I can do the antiderivative. Yeah, so let's see, negative cosine of u, so I will need that parenthesis, plus c, they're indefinite integrals. Okay, and here's the last step, is we wanted it in terms of x. We changed it to u, so then you got to change it back to x at the end. So this sometimes students, they leave like this, just forget. I got to change it back.
Wait, why doesn't the du go down?
Well, just because normal antiderivative, that's just a variable that you're integrating in respect to. That's all it says. It doesn't. If it was dx, you'd be integrating with respect to x. It essentially disappears there. So all I'm doing now is just changing this back. U was x cubed. Okay, that's it. So again, here's the process. I pick u. You're going to choose a u wisely. For now, it's pretty much the inside function. Right, you see a composition, you choose u as the inside. You do its derivative. Okay, just on the side here. Okay, it's 3x squared. Is that on the outside? Yes. Well, I substitute du, the derivative, in there. I could have called it u prime, it's just we generally say du. And I put in u for x cubed. Now I can do the antiderivative. So essentially what you do is just take it back so you can use a basic antiderivative rule. Do antiderivative as normal, plug in u to finish up. Okay. And here's what I want to show you is if we, basically what we did here, we got the antiderivative. We got the derivative to exist outside here, 3x squared dx. So therefore, we could just simply take it, we could just do, all right, the full derivative of this is on the outside, then we could go backwards. By the way, a quick check here. If I did the derivative of this, cosine's derivative is negative sine of x cubed times the chain rule, with the derivative there would be 3x squared. And that's what we started with. So on all of these, you can actually check every single one by doing the derivative at the end. So, okay, that's our first one. And we're going to see a couple more here where, okay, basically the same, but there's going to be a variation in a lot of these. So, any other questions? Yeah.
So, why do we do the du thing in the beginning?
Because I want, in order for this to work, I need the derivative of u, whatever I chose as the u, the inside, in this case x cubed. I need that to exist on the outside and be multiplied by it. So I'm just doing the derivative to check and see, does it?
Oh, it's just a check.
Yeah.
Okay.
And you know what, this reminds me. Sometimes students are like, well, what if it was like 3x cubed on the outside? Well, we couldn't do it. We just wouldn't, this method wouldn't work. Because we needed it to be 3x squared. So sometimes, yeah, you just can't do it with the u substitution method. But right here, you need the derivative of your u to be on the outside. Then it will work. Anything else? Good question. Let's try a couple more here, so just so we can keep seeing the process here. The next one is square root of 4x minus 1. We know how to do square root of x, but we haven't seen 4x minus 1. So I'm going to do, so again, antiderivative? No, I don't know it. But I can do some u substitution. So I'll let u, in general for now, be the inside 4x minus 1. I'm going to write it down here just so I can work down the page. Then I do the derivative to check and see if it's on the outside. So du, the derivative is 4. And put the dx with it, so then that'll carry forward.
Wait, why does the 4 go with it?
Oh, I'm doing the derivative of this one. That's what he said. Okay, so this one's fun here. So now I'm going to do the integral. I'm plugging in u. So it'll be square root of u. I look up here, do I have a 4 dx on the outside?
No.
I don't. I have a dx. But, I mean, 4 is just a number. Can't I put a 4 in there? I can if I then cancel it out. So what I'm going to do is I'm going to throw a 4 in there, but I can't just randomly put a 4 in unless I cancel it out. So I'm also going to put a 1/4 in, or divide by 4. Would you guys agree that 1/4 times 4 cancels itself out, right? It becomes 1?
Yeah.
Yeah? So what I'm doing is the 4 is going to go on the right with the u substitution. And the 1/4, I'm just going to put on the outside. So this 1/4 just slides in front. Any coefficient can just slide out front. But this 4, so go like this 4 I need. So I'm going to write it here as 4. I guess for now I'll write it as 4 dx. Sometimes you might just, well, once you get the hang of this process, you probably just immediately, you won't do this step. You'll jump right to the next one. So then what I can do, square root of u, and then 4 dx is really du. And we need to do that. We need to make sure we have the du in there, because we want to integrate in respect to the correct variable. So again, this one didn't look like it would work. However, I can make it work. I can put a 4 in, cancel it out with a 1/4, but then separate where I want the 1/4 and the 4 to go. So the 1/4 goes outside, the 4 goes with the dx. And then again, I just substituted in place of 4x, I put du. All right. And now it's just a normal square root of x type antiderivative. So I'll keep the 1/4. Let me change it to u the 1/2. Okay, now I'm going to need an antiderivative. Okay, so I'm going to bring the 1/4 down, and I'm going to do the antiderivative of u the 1/2, which is u the 3/2 over 3/2 plus 7. I will, instead of dividing by 3/2, I'm going to change it to multiplying by 2/3. So this will be 1 times 2 is 2, and 4 times 3 is 12, which will reduce to 1/6. Then I'm going to put in u, so it's u to 3/2, but my final step is just putting back in what u was. And u was 4x minus 1. I keep the 3/2 plus 6. So that was a good one where we can see it doesn't look like it might work, but you can kind of force some of them to work with the coefficient. If it was like an x that needed, you can't. I couldn't have put like an x and x, like 1/x to cancel it out, because you can't bring that outside of an integral. So only if it's coefficient, I should add that a number. Okay, let's keep going a little bit here. Any thoughts on that one? Okay. Let's do a trig one now. So I've got cosine of 7x plus 5. I say to myself, I don't know how to do, I know how to do cosine of x, but not cosine of 7x plus 5. So I try some u substitution. And I let u be the inside, 7x plus 5. Let's see, so then my derivative, I'm checking here, the du, the derivative, is just 7 du, that's dx. Derivative 7 and the derivative 5 is 0. So I start to set up the integral cosine. I put in u for 7x plus 5.
What does it say next to the 7?
And then, yeah. I'm sorry?
What's next to the 7d?
Dx. It was a du, and then I crossed it off.
Gotcha.
Just went with the x there. Yeah, so I put this one here because I wanted you to see if you could. It's basically the same as this one, but if you could see it, and you don't have to write the whole step here. So I put in u there. Now I need the derivative on the outside here to be 7 dx, but it's not. So here's really what I do the problem, so I don't have to take an extra step. I just put a 7 here. So now it would work. And I cancel it out with the 1/7 in front. So then I just bring this 1/7 down here, and this 7 dx becomes du. So it's basically the same as the last one, but I really wrote the numbers up here that would cancel out. Okay, and now it's an antiderivative, and you can work it out. The 1/7 comes down. Integral of cosine is sine of u plus c. And then just plug in u. So it was 7x plus 5 plus c. Okay. So there's too much room there, but hopefully I guess there's plenty of space if you need to work it out, take any notes. Let's see, thoughts on that one?
So once you like write out the du like that, you can just pretty much forget about it after that.
Yeah, because this just says do this antiderivative in respect to the u variable. Yeah, it's really just cosine of u there. Yeah. Okay, let's do a couple more on the next page. So again, what I'm doing here, everything is just slightly advancing here. So let's do the next one. The integral of sine of the fourth x cosine x dx. I don't know an antiderivative for that. Okay, so all these you just want to look. Okay, do I first know the basic antiderivative rule? No. Okay, where do you see a composition?
Is the sine 4x?
Because really, let me write out what it really means. This really means sine of x to the fourth power. So even though they write it like that for convenience, it really means sine of x to the fourth power. Cosine of dx. And that's where you're exactly right, that's where the composition is. So here, let me ask you, what should I say is my u? Again, u is the inside part, if there is an inside, not always, but.
X to the 4th.
Mm-mm.
Sine x to the 4th.
Mm-mm.
4.
Sine x.
Sine x. Yes, good teamwork. Yeah, we want to be the inside. Here, I'll go back on these. You know, here the inside was the 4x minus 1. Here the inside was x cubed. Here the inside was the 7x plus 5.
It's in the inside.
In general, now we're going to see in our next example where it's not going to happen, but yeah, you start. You gotta choose wisely with u. It's not. If you don't, then it's not gonna work. But yeah, this one I choose u as sine x.
I'm sorry.
Oh, you're fine. All right, so let's let me do the derivative. Du. Oh. So I do the derivative du. Check, and it is cosine of x dx. And hopefully, right there, you're already looking and seeing like why this works. Yeah. Now, let me go ahead and plug things in. In place of sine x, I'm putting u. So it'll be u to the fourth. Then right here, cosine x dx is right there. It's just du. So on this one, we didn't need to do like we did on B or C, where we had to introduce a number that canceled it out. We didn't. We just had to really translate this to mean sine x to the fourth, and then choose u. So I put in u for sine x. I put in cosine x dx is actually equivalent to du. Now it's set up. You get a cough drop or something?
I have one in and I just can't stop coughing.
Well, sorry about that.
No.
I don't know what to say.
I don't know what to do.
Hope you feel better. Hope you feel better.
It's never happened to me before.
You put this pause in between your words sometimes.
I didn't know what to
It's
say.
so funny.
I was at a loss for words.
Yeah. So
What is it?
it?
What does a tree do? I like I have trees. So. All right.
So bad.
Power rule, right?
Write it in your mouth.
U to the fourth. I can do power rule. So it's u to the fifth over 5 plus c.
How many sprays?
It's
Like two?
nasty. It's like really bad.
Two sprays.
And finally, I put in what u is, or was. It was sine x.
Yeah.
I got one drop.
Yeah. I'd like to finish up with 2 more, but that one again, we see just a little more. We got to kind of choose u wisely.
It's actually crazy how that works.
I know, it's beautiful though.
It's the journey.
Indeed. And hopefully what you're seeing already too is like, hey, this offers us so many more antiderivatives we can do. Well, let's move on to cosine cubed x. So let me get rid of this, just I need a little more room here. All right, Tony, cosine cubed x. So this really means cosine of x cubed. So based on the last one, indeed, what do you think I should say u is?
Cosine x.
The inside, right? Cosine x. Now, I then check du. I say, all right, the derivative. Let's see. Derivative of cosine x is negative sine x dx. Is there a sine x somewhere on the outside here?
No.
No. And you can't do what I did in B and C. Okay, you can't introduce a sine x and then do 1 over sine x, cancel it out. That's all.
Cosecant.
Oh no, hold up. It's only if it's a number that you can do that. All right, so if it's x, I can't do anything like that. No, basically on this one, it didn't work. All right, our choice of u did not work. So if you want to maybe just, instead of erasing, maybe just cross out, like you can say like our basic, our normal choice, that's what you should do. It didn't work. So what I'm going to do, that we can actually still do this one by use substitution. What I'm going to do though is I'm first going to change this. So I'm going to change cosine cubed x, or cosine of x cubed. And I'm going to write it as cosine squared x times cosine x. that because cosine times cosine squared is cosine cubed.
Sir, are you making this up?
No.
You can just.
Again, integrals are harder to do, so derivatives are just, hey, follow the rule. Integrals, there are methods that you have to
You
actually
really
do.
could be making this up and have no idea. Like, you would know no different. Like, you could
I
just
just-
literally do whatever you want up there.
You know that this is
Okay.
true. Cosine
Yeah.
squared x times cosine x is
But
cosine
do I
cubed
know
x.
that's true?
You know that's true, right?
Yeah. Do I know
So
that's
watch
true?
what happens.
You told me it's true, but can I trust you? Is it true?
Of course, why would I lie to you? So I use a trig identity. What's equivalent to cosine squared x?
Sine squared x.
Yeah. This is based on Pythagorean identity.
1.
So
When am I ever going to use this?
cosine squared x therefore is 1 minus sine squared x. Right, this is from the Pythagorean identities. Do not question me, Cassidy. Okay, so right, just if I subtracted sine squared x from the Pythagorean identity here, so 1 minus sine squared x is cosine. Okay, and now what I can do is u substitution will work. So I'm going to look here. The only composition, nothing with cosine, nothing with 1. There's a composition here, because this one really means sine of x squared. Right, it really means sine of x squared. So what I'm going to do is let u be the inside, which is sine of x. I check du, the derivative is cosine x dx. And it works. Do you see that? The derivative right there is on the outside.
Yeah.
Cosine x dx. So that just confirms that it worked. So now I'll go ahead and fill in u. So the integral of 1, parentheses, 1 minus, well I chose u as sine x. So it's going to be u squared. Then on the outside, cosine x dx is just du. So I'm plugging in du here, and now we're good. And I'll be able to do an antiderivative. So this is in respect to the u variable. So the antiderivative of 1 is u, so x, minus, and then u cubed over 3 plus c. Last step is just plugging in what u was. So I'm running out of room a little bit, but what was it? It was sine. Oh, it's right there. So plug in u, sine x minus sine x cubed over 3 plus c. Weird box. And yeah, I mean, again, you could check this, do the derivative, and you could get back to, what was our starting one?
Shut her down.
Cosine cubed x. I said I wanted to do these last two, and then
Let's shut her down.
I see 2 up there. 2 down.
no, I
Yeah.
I finished this one. Then I said, all right, I want to do these last two, a little more advanced.
Then you'll have to erase that.
I know. So we get on that one?
Just ask some more questions.
No,
Wait.
no more questions.
I know.
How
Wait,
fast are you
I don't
gonna
understand. I think
So I
you
started-
guys
What
he's gonna play tomorrow.
about that DX?
He's in
thing?
Cali right now. Cali tournament. All right, so last one. This is tangent of x. This is one I said. Well, we knew that the here. I'll go back. The antiderivative. Where is it at? Here. The antiderivative of secant squared is tangent. But we never did the antiderivative of tangent itself. Okay. Thank you, Taryn. Please stop.
It's not.
Sorry. You can borrow pencil up there if you need it. All right, so antiderivative of tangent. It's going to be u substitution. What should I choose as u?
Wait, you can't put this, yeah, you can't.
There is no u right now. There's nothing to.
Something to you.
Yeah, it's just.
But if you went to secant squared, then you could do secant.
Good idea. By the way, some people say you never let u be x, because all it does is it would change. I've seen that before. Somebody has said on this before, let u be x. Well, it doesn't change anything. It's still changing to u.
Need a number.
It's got to be more than just x. Okay, so I like what you're thinking, but no, let's change this to something else. What can I change tangent to?
Sine over cosine.
Yeah.
Tangent is equivalent to sine over cosine. Now, we just need to choose one of those as u. Now, I know there's no composition, right? It's not like sine of 3x minus 4. But u substitution will work if we choose one of those as u. And really now, if this is your first time doing this one, you just have to try one and see if it works. So what do you want to go with? Do you want to try u being sine or cosine?
Sine.
Sine.
Sine?
That's the wrong one.
Is it the wrong one?
Let's check. The derivative is cosine.
The right one.
Hold up. So it would be this. It would be, I'd put in u there for sine. But then it would be du would be cosine's on top there. Like it would be here dx. I need it to be like the cosine's on bottom. I need this to be right here up top. So yeah, I think we chose poorly. So let's go back and choose it to be cosine x. The derivative of cosine du is negative sine x dx. So see, just look up here. Did this work? Well, yeah. It altogether sine x dx is right here.
Yeah.
Right. Now the only thing we need is we need it to actually be negative. So what I'm going to do is I can put in a negative there, sure, but I have to cancel it out with another negative. Right. Just like doing it would be like 4 and 1/4 are there. I can put a negative in and cancel it out. Okay, and then now this is it. We're going to be set up. So I bring this negative down. Integral sign. I'll go ahead and put in u on bottom for cosine. And then the numerator, I'm just going to have du, because negative sine x dx is du. We know this antiderivative. It might help if you think of it as 1 over u. What's the antiderivative of 1 over u?
ln.
ln absolute value of u plus c. Last step, plug in u was cosine x. That's it. That is the antiderivative of secant squared was tangent. The antiderivative of tangent is negative ln cosine x plus c. This would also work for cotangent.
Use the opposite and be sine.
Same idea basically.